All right, everybody, this is going to be number 10 on chapter 4 review on vectors. So number 10. An arrow is fired from a bow with an initial velocity, and these two velocities, initial velocity and final velocity, are given to us in unit vector notation, which is kind of nice because we don't need to find the components. We're given the components. The initial velocity is 35.0 meters per second x hat, that is in the x direction, and 25.0 meters per second in the y hat direction. Final velocity is 34.0 meters per second in the x hat direction, and it's got 5.30 meters per second in the y hat direction. So it decreased a little bit in the x, and it decreased quite a lot in the y. All right. Okay, so we're asked to find what? By the way, the time that is elapsed, it tells us that it's 2 seconds later. So time equals 2.0 seconds. Okay, so we're asked to find the average velocity. Sorry, the average acceleration. Too many A's. AAV right there is what we're solving for in part A. All right, part B, we're simply going to, by the way, part A, we're going to solve for that in unit vector notation. Unit vector. And in part B, we're going to state the same thing, but in magnitude direction notation. Okay? So, what's our definition of acceleration? Acceleration is change in velocity over time. All right? We've got time, we've got an initial velocity and a final velocity. All we need to do is determine what a change in velocity is and divide it by time, and we'll have our acceleration. Okay? So, AAV equals change in velocity over time. Well, that means V final minus V initial, right? Over time. Which means if we know how to subtract these unit vectors, we should be able to divide that by the amount of time and have our average acceleration in unit vector notation. So, how would we subtract our unit vectors, final velocity minus initial velocity? That's going to be the final velocity x hat minus the initial velocity x hat, right? So that's going to be 34, I'm going to leave off the 0.0 for simplicity's sake, minus 35 x hat, and 5.3 minus 25 y hat. 5.3 minus 25 y hat. All that divided by time. Okay? So I'm going to write it down below. What's 34 minus 35? That's -1. This is velocity, right? So meters per second, x hat. And 5.3 minus 25, that's minus 19.6, right? Minus 19.6 meters per second, y hat. All divided by time, right? Divided by time, how many seconds? 2 seconds. Divided by time, 2 seconds. So we're taking a velocity vector in unit vector notation, x hat and y hat. Or actually, it's a change in velocity vector, final minus initial, x hat and y hat. And we're dividing it by time, just like we divide change in velocity by time in order to get our acceleration. So what's that going to simplify to? Our acceleration, our average acceleration is going to be, I think I wrote that up a little bit too high. I'm going to write it down a little bit lower. Average acceleration is going to be -1 over 2. Well, that's pretty easy. I can do that in my head. That's going to be -0.5 meters per second squared. So that's the acceleration in the x hat direction. And what's 19.6, or -19.6 divided by 2? Go to error. Oops. An extra. -9.8. -9.8 meters per second squared. That sounds familiar. Y hat. And that's our acceleration. So it slowed down a little bit in the x direction. It slowed down quite a bit in the y direction, probably because of gravity. But that's our answer for part A. That is our acceleration in unit vector notation. Real quick, part B, we're asked to find, all right, well, what is that in magnitude and direction? well, it says calculate the magnitude of the average acceleration. Let's find magnitude and direction because we're used to that. All right. So the magnitude of vector, of the average acceleration vector, we get the magnitude by taking the square root of the x squared plus the y squared, right? It's 0.5 squared plus 9.8 squared. Again, I left off the minus signs right here because they're going to go away anyway. What's that? 0.5 squared. 0.5 squared plus 9.8 squared. Square root of that. That does not seem... Oops, I'm sorry. 0.5 squared. 0.5 squared. I'm having problems right here. Plus 9.8 squared to the 1/2 power of square root. That makes sense. Not very much difference, but 9.81 meters per second squared. That sounds even more familiar. At what direction? All right, well, the direction is going to be the inverse tangent, so the direction of the average acceleration, AAV, is inverse tangent of what over what? The y over the x. So that's going to be 9.8 over 0.5. Okay? Inverse tangent, 9.8 divided by 0.5. 87 degrees, or 87, degrees. 87 degrees. All we need to determine is, what's the direction? Well, I've got a negative y and a negative x, right? So that's kind of like that right there. So that's going to be south of west. So that is our magnitude, 9.81 meters per second squared, which should look familiar. And our direction is that it's directed at 87 degrees south of west, or very nearly vertical. All right? So that's our answer for number 10, part B. All right? I hope that helps. And again, good luck on your test. We'll see you when I get back.